So the third question that we have here, we have been given 2 moles of helium gas with a gamma value of 5/3 and temperature equal to 300 Kelvin and volume is equal to 20 liters initially. Now the gas is expanded isobarically, that is at constant pressure, to double its volume. Now this gas goes another process, another adiabatic process, in which its temperature reduces to its the temperature comes back to its original value of 300 kelvins. We need to find out the final pressure and volume of the gas after this process and the work done by the gas in the whole process. So to get an idea of what is happening, the first best thing to do is draw the graph. It's generally more comfortable drawing the pressure volume graph, so I am drawing the pressure volume graph. This just gives us a clear picture of what is happening, so it is always advisable to draw the graph first. Initially 2 moles of helium gas was at a temperature of 27 degrees Celsius and 20 liters. Let this be 20 liters. So initially the gas was at this point with a pressure of, the value of the pressure is not given, the temperature is given to be 300 kelvins. The temperature here is 300 kelvin. This is, let this be point A. Now under constant pressure it doubles its volume. So it goes to a point where the volume is doubled. The volume at this point will be 40 liters. Let this be point B. Now the gas returns to its original temperature. Original temperature means the temperature at this point via an adiabatic process. Now since it is returning back to the original temperature, let us draw an isotherm over here. The point C to which the gas finally comes must lie on this isothermal curve of 300 Kelvin, because in a pressure volume graph the isotherms are all like this. So here we have an isotherm. The temperature at this point C will be 300 kelvins and the gas came through an adiabatic process to this point C from point B. So this gives us a final clear picture of what is happening. The gas went from A to B and then came back to C from B via an adiabatic process. This is an adiabatic process. So we now need to find out the final pressure and volume of gas. So we need to find out PC and VC, that is the pressure and volume of the gas at the point C. So for that, let us first write the equation PAVA is equal to PC into VC. This is true because A to C is an isotherm, therefore PAVA is equal to PCVC. Now for this adiabatic process, we know that PV raised to the power gamma is equal to constant for an adiabatic process, therefore PB into VB raised to the power gamma is equal to PC into VC raised to the power gamma. Using PV raised to the power gamma is constant for an adiabatic process, therefore now PB is equal to PA, therefore we can write PA. VB is equal to 2 times VA, therefore we can write 2VA raised to the power gamma, that is equal to 5/3 is equal to PC into VC raised to the power 5/3. Now checking out these two equations, if we divide them, we get VA upon 2 raised to the 5/3 into VA raised to the power 5/3. This is equal to VC upon VC raised to the power 5/3. Therefore what we get here is that VC raised to the power 2/3, this is equal to 2 raised to the power 5/3 into VA raised to the power 2/3. Therefore we get the value of VC in terms of VA, that is VC raised to the power 2/3 is equal to 2 raised to the power 5/3 into VA raised to the power 2/3. So now let us take power 3/2 on both sides to give us VC is equal to 2 raised to the power 5/3 into 3/2 into VA. This gives us VC is equal to 2 raised to the power 5/2, that is equal to 4√2 times VA. Now the value of VA is given to be equal to 20 liters. Therefore the value of VC comes out to be equal to 80√2 liters. So now the second part left is to find out PC, that is the pressure at the point C. This is pretty simple. We can write PAVA is equal to PCVC. PAVA can be written as nRTA. Number of moles is given 2 into R into temperature at A, that is 300. This is equal to PC into VC. The value of VC is given here, 80 root 2. On solving this, we get the value of pressure PC to be equal to 4.4 into 10 raised by 4 pascals. So we get the value of PC and VC. Now we need to find out the work done by the gas. Let us write the answers over here. This is 4.4 into 10 raised by 4 pascals. This is 80 root 2, that is around about 113 liters. So now we solve for work done by the gas. So we now need to find out the work done by the gas. The work done by the gas in the whole process can be broken into work done by the gas from A to B plus work done by the gas from B to C. Work done by the gas from A to B is pretty simple because it is an isobaric process, that is constant pressure. At constant pressure, the work can be written as P into V final minus V initial. This is equal to NR T final minus T initial, because P into V final is NR T final, this is NR T initial, that gives us NR delta T. Now we know that for this constant pressure process, VA upon TA is equal to VB upon TB. Now VB is equal to 2 times VA, therefore TB is equal to 2 times TA, that is TB is equal to 600 Kelvin. So delta T is equal to TB minus TA, that is equal to 300 Kelvin. So we substitute that here. Number of moles is 2, the value of R is 25 by 3, delta T comes out to be equal to 300 to give us the work done from A to B to be equal to 50 into 100, 5000 joules. Now we need to find out work done by the gas from B to C. Now B to C is an adiabatic process. For an adiabatic process, work done can be directly written to be equal to P initial V initial minus P final V final upon gamma minus 1. It is important to remember this formula. The work done by the gas is equal to P initial V initial minus P final V final upon gamma minus 1 in the case of an adiabatic process. Now P initial V initial, that is PB VB. Instead we can write this as NR T initial minus NR T final upon gamma minus 1. This is equal to NR, that is 2 into 25 by 3 into T initial minus T final upon gamma minus 1, that is equal to 2 by 3. So this gets cancelled. T initial is TB, this was 600 Kelvin as we had already found out. 600 minus 300 is 300, therefore this becomes equal to 7500 joules. So the total work done by the gas from A to C is equal to this plus this, that comes out to be equal to 12500 joules. So final answer for the work done by the gas comes out to be equal to 12500 joules. So what we learned from this question was that making a graph and interpreting them to solve questions is really very helpful, and we thus get the final answer for the pressure of the gas to be 4.4 into 10 raised to 4 pascals, the volume of the gas to be 113 liters, and the work done by the gas to be equal to 12500 joules in the whole process.